Alrighty, here we go. We're going to talk about solving logarithmic equations. I want you to be able to solve logarithmic equations and inequalities. It's not that difficult. It can be easy, but you got to be able to listen. So you got to listen very quick, guys. All right, here we go. So let's look at an example, shall we? Boom, 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 dun, 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 dun. 36 log base 36 of x equals 3/2. Oh no, what can I do? Well, if you know your exponential form, then you would know that 36 to the 3/2 power, oh my goodness, that's right, is equal to x. Oh, and then all you got to do is say solve and say, well, type into the calculator 36 to the 3/2 power. So that would be like the square root of 36, which is 6. Then cube that, which gets you 216. And there you go. It's that easy. Yes, it can be. Yeah, I'm getting a little too excited. All right, anyways. Here's another example. Log base 9 of x is equal to 5/2. Again, all you got to do is say x is equal to 9 to the 5/2 power. Remember, this is the base, this is the exponent. So you can easily convert like that. And then just solve that to get 243, and there we go. Let's up the difficulty level, shall we? Oh no, I don't think I can do this one, sure. Okay, so we're saying log base 3 of 2x minus 5 is equal to 3. Well, again, then we're just saying 2x minus 5, that number, or that answer, whatever you want to call it, is equal to 3 to the 3rd power. Bada bing, bada boom. Okay, 3 to the 3rd power is 27, and now we're just solving a simple two-step equation, so there you go. All you got to do is add 5 divided by 2, and you got your answer of 16. Now, it is important that you should probably check these answers and kind of go from there. Now, something to remember though, logs are again the opposite of exponents. Exponents, remember, the range was always greater than 0. Well, it's kind of the same thing for logs, but it's the domain that has to be greater than 0. So here the domain is not equal to all real numbers. Okay, so what happens when you have a log on both sides? Well, first off, I have to give it to you as the same log. Okay, we'll get to those later when they are different logs, but right now they have to have the same base. So if they had the same base, just like in the exponentials, you can get rid of them and set the two sides equal to each other and start solving. Hey, but you gave me squared. I have to remember how to do squares again. Do the factoring. If you factor this, you will get x minus 4 is equal to x minus 4, x plus 1 is equal to 0. Set them both equal to 0, and you would get x is equal to 4 or x is equal to negative 1. Now, here's the next part. You have to check both answers. You have to check it. You might start seeing some shortcuts here, but here's the reason why we have to check it. Because if you do this, and you can see I'm putting 4 in place of the x, and then I will put the negative 1 in place of the x. I want to make sure both sides are equal to the same thing. If you get, like, say, a negative, then it doesn't work. And what I mean by this is like this. There is no way I can get raised 2 to some power, multiply 2 by itself, to get a negative 3. So I cannot have log base 2 of some number equal log base 2 of some negative at all. So then that means negative 1 doesn't work, and my only answer here is x equals 4. Okay? So again, here, with logs, your domain has to be greater than 0. So when I checked x4, I got log base 2 of 12 equals log base 2 of 12. That checks. But when I have log base 2 of negative 3, there is no way for me to say 2 to some power can give me a negative 3. And so that doesn't check, so negative 1 is not an answer, only 4 is. So always make sure you double check your work. Let's do another example. Dun, 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 dun. And here we go. We dropped it to log base 3 and said x squared minus 15 is equal to 2x. Move the 2x to the other side. And now I'm saying, okay, I've got x squared minus 2x minus 15. This is I'm making them simple. You should be able to factor. So you kind of see some things that we've covered before. You can't just, I've taken a test on it, and now let me toss it outside of my brain. No, it has to stay inside the brain. So I've got a negative 15, I've got a negative 2, minus minus is a minus plus, which means in the parentheses I've got a minus plus. Two numbers that multiply to give me 15, but would subtract to give me a negative 2 would be 5 and 3. So I'm saying 5 and 3, and that means that my answer is x equals 5 and x equals negative 3. Or does it? Let's check the work. So I pop it in, put in the 5 into the x of the original equations, and I get an answer of log base 3 of 10, which there is a way for me to find that. So yes, that checks. Pop in the negative 3, and notice how I'm making sure they're in parentheses and stuff, and I get log base 3 of negative 6 equals log base 3 of negative 6. That is not possible. So again, my answer here is only x equals 5. All right, so what about inequalities, sir? Well, there's a special rule about inequalities. Oops, went a little too far. Hold up. Let's go back to right there. No, right there. Okay, there. All right, so here's the thing. B, the base, is going to be greater than 1. X is going to be greater than 0. So they're saying if you say log B of x is greater than y, then the answer is x is greater than b to the y power. If you say it's less than y, then it has to be between 0 and b to whatever power. So what do I mean by that? Okay, so I mean like this. If I say log base 3 of x greater than 4, since I used the greater, then x has to be greater than 3 to the 4th power. So x has to be greater than 81. If I say log base 2 of x is less than 4, notice there, now I'm using less than, so I'm using the second rule. Then the answer has to be x is between 0 and 2 to the 4th power. And thus, so x is between 0 and 16. Okay, very simple, nothing too difficult. I'm going to keep it like that. There was another thing about like with the logs of same bases, and I was just like, yeah, no. So here is our basics of solving some logarithmic equations, and that's it for today. Have these notes ready, and I will see y'all next time. Y'all take care.